How we doing, guys? Looking at a concept called congruence today. And two shapes are said to be congruent if they are the same. So you might say, well, are these two shapes, are they the same shape? They look like they might line up on top of each other, and sure enough, there you can see they do. So those are the same shape, except for one has been rotated, or maybe one has been flipped over one way. Okay, so these are congruent triangles. And the way, or one way we can show congruence is, well, if we look at them, we can say they have the same angle in all three sides, or in all three vertices. Okay, those angles are all the same in both of our triangles. They have the same sides. They have sides of common length. Okay, these two sides are the same length, or these two. Okay, so if you can lie them on top of each other, basically, then they're congruent. Now, it turns out this is a really, really important concept for when we do mathematical proof of theorems later on. So I want to talk about it a little bit now. First of all, how do we prove congruence? Well, we prove congruence by showing that two triangles either have the same three sides. Okay, so this is actually all on page 178. Okay, so if they have the same three sides, it's called the side-side-side case. If they have two common sides and one common angle, like here, two common sides, one common angle, then those two triangles are congruent. Here again, two common sides, that line means it's the same length as this line. Double line means the same length as this double line here. Two common sides and one common angle, then they're congruent. That's the side angle side case. If we have two common angles, so the red dot and the red curve, and one common side, that single line, then we say they're congruent. It's the same triangle, except for a rotation. Or that's the angle side angle case. Or if they have a right angle, the same hypotenuse, and one other side in common. That's called the RHS, right angle hypotenuse side case. In the case of two congruent triangles, you'll say this side here, BC, that is the same length as this one here, EF. They're called corresponding sides. Okay? So if sides in a corresponding, in congruent triangles, corresponding sides are equal and corresponding angles are equal. Okay, so down here, their red triangle, this side here is corresponding with this side here, and they're the same length. Okay, again, this angle here and this angle here, they're the same size, they're corresponding angles. Okay, so let's have a look at some questions. So on page 178, keep coming back to 178 for that side angle side, angle, or right angle hypotenuse side case. If I have a look at question 2, I'll just go through. It says, state why each of the following pairs of triangles are congruent using one of these reasons. So here we've got one triangle with 5 centimeters, 4 centimeters, 7. Look, 5, 4, and 7. So it's the same three sides. So because of our side condition, we can say these two triangles are congruent. Here we've got an angle in common. Okay, and 3 corresponds to 3 up here, 5 corresponds to 5. So we've got an angle and two corresponding sides. That's congruence according to the side angle side condition, side angle side. This again, side angle side corresponds to 5, 36, 6, side angle side. Here, this angle and this angle are corresponding, this angle and this angle are corresponding, and this side and this side. So that's angle, side, angle. Here you've got a right angle, a hypotenuse, and one other side. Right angle, the hypotenuse, is the longest side, or the side opposite the right angle, in a right angle triangle. Well, they're the same in these two, and the third side is the same length. So that's our right angle hypotenuse side condition. And here, 9 centimeters and 9 centimeters corresponding. 35 and 35 are corresponding, 70 and 70 corresponding. So that is our angle side angle condition. Angle side angle. Okay, question 4 asks, state whether the following pairs of triangles are congruent. Give reasons for your answers. Okay, so this first pair, if you work out the missing side there, sorry, let me grab a pencil. The missing angle in this triangle with 52 and 68 is 130, which leaves me with, 52 and 68 is 120, which leaves me with the 60-degree angle down here. Or 68 and 60 is 128. So 180 take away 128 leaves 52 degrees here. So are these congruent triangles? Well, we've got a corresponding side of 35. That is between a 52 degree and a 60 degree angle. Corresponding side 35 between a 52 degree and a 60 degree angle. So yes, this first pair of sides are corresponding. And the way you write that down, I've got it written down here. You'll say AC is the same length as PR. That's what that says. AC is the same length as PR. Then you'll say the angle CAB is the same size as the angle PRQ, because they're both 52. And lastly, you'll say the angle ABC, 68 degrees, is the same as the angle PQR, also 68 degrees. So these, yes, they are congruent, and that is by the the angle, side, angle condition for congruence. The second one, this is a bit of an interesting one because it looks right at first. You've got two corresponding angles, but these sides are not corresponding. That 7 is between the 32 and the 80 degree angle, whereas between the 32 and the 80, you don't know what that length PQ is. So even though they look like they're the same length, they are not corresponding sides. So 4 part 2, no, that is not corresponding. Question 6, explain why these angles, AOB, the triangles AOB, that's how you call that triangle, and this triangle here, COD, explain why those are congruent. Okay, well, I've redrawn that here. They've also given us, that I don't have in my diagram, a double line on AO and OC, which means those are the same length. And we've got a single line on BO and OD, which means those are the same length. You'll also remember that vertically opposite angles like BOA and COD are equal. So we can say that the line BO is the same length as the line OD. We can say the line AO is the same length as the line OC. Now both of those were given in the question. So that's all you have to say in terms of justifying it. But this last point, that the angle BOA is equal to the angle COD, that wasn't given. We know that because they are vertically opposite. Okay, so you need to justify your 3 steps in proving, yes, side, side, angle, these are congruent. Triangle BAO, this triple equal sign means is congruent with, BAO is congruent with COD. The triangle COD, because they have a corresponding side, angle, side. Okay, it doesn't actually matter what order you put that in if you want to do SSA or anything. Question 8 says these triangles are congruent. Okay, so they tell you they're congruent. You don't need to prove it. Write down the value of y and of x. Okay, well, if we come over here, y is this distance here, and x is this angle here. I've actually made these drawings to be the same size as those original triangles I worked with. Sorry, there's a bit of a mess up there. But if they are congruent, well, it means you should be able to just rotate them or flip them around, and you should be able to fit this triangle into the other one. And sure enough, there it is. Okay, so let's come back up here and say, well, how do I rotate that? That's my 70 degree angle. That's my 30 degree angle. Okay, and I know this is 10 and this is 5. So if I want to fit that in, I need to get the 30 degree angle up here. But look, it doesn't quite fit in there. Oh, well, actually, it does fit in there, but the way it's supposed to fit in is here. Turns out I've made myself an isosceles triangle by accident. The 10 fits over on this side here, okay? You can't have, obviously, that 9.5 centimeter side is not a 10 centimeter side. So we need the 10 on this side here. Our 30 degree angle is up there. So what was under here? Well, that was our 70 degree angle. Okay, you can see it there. So x is going to be 70 degrees. and y is our 10-degree angle, or sorry, our 10 centimeter line. So just by rotating your first triangle, you take it here, okay, and now, you sit it in there, and you rotate it around and flip it. So that's how you say, oh well, y then is the corresponding side with this. X is the corresponding angle with this. And you can come along and say, well, that has to be 5 centimeters and this has to be 9.5 centimeters. Okay, so that's as much as I'm doing now.